We will now solve examination questions, but before we do that, we will take note of the important skills you need to have in order to solve the past year questions. The first skill you need to have is definitions. You need to be able to define nuclear binding energy and nuclear binding energy per nucleon. Then you need to know what is atomic mass unit U. Calculations. You must be able to calculate nuclear binding energy and nuclear binding energy per nucleon. Conversion. Converting mass in atomic mass unit to kilogram and from kilogram back to atomic mass unit is important. Similarly, you need to be able to convert electron volt to joule and joule back to electron volt. Mass defect is binding energy. The relation between the two is E equals to delta M C square. Delta M is your binding, is your mass defect. You need to be comfortable converting delta M to E and E back to delta M. Then you must know the graph of binding energy per nucleon against nucleon number. This is a graph. The graph goes up and then come down. Then you must be able to use the graph of binding energy per nucleon to calculate the energy released during nuclear fusion and nuclear fission. When A and B combine to form X, A and B are two smaller nuclei. X is a bigger nucleus. That's nuclear fusion reaction. It releases energy from the graph. And then when P is a heavy nucleus containing many protons and neutrons, it's split to form Q and R, which are two lighter and smaller nuclei. That's nuclear fission. Energy is also released. You must be able to calculate energy released during nuclear fusion and nuclear fission based on the binding energy per nucleon on the graph or the binding energy which are provided for you. In this past year question for May, June 2011, variant 4.3, question 8, we have to state what is meant by the binding energy of a nucleus. The binding energy of a nucleus is defined as the energy needed to separate the protons and neutrons in a nucleus to infinity. Then in part B, we have to show that the energy equivalence of one atomic mass unit is 930 mega electron volt. We know that 1 U is equals to 1.66 times 10 minus 27 kg. Then use E equals mc squared to calculate the energy equivalence of this mass. So E equals to mc squared. M is 1.66 times 10 minus 27 times c squared. This will give you 1.49 times 10 to the power of minus 10 joule. Then the energy in electron volt will be equals to 1.49 times 10 minus 10 divided by 1.6 times 10 minus 19. This will give you 933 times 10 power 6 electron volt, which is equivalent to 933 mega electron volt. Data for part C, data for the masses of some particles and nuclei are given in figure 8.1. This is a mass of the proton. This is a mass of the neutron in atomic mass unit. This is a mass of deuterium, and this is a mass of zirconium. Use data from figure 8.1 and information from B to calculate in mega electron volt the binding energy of deuterium. To calculate the binding energy for deuterium, we'll do 3 steps. In the first step, we'll calculate the mass of the individual protons and neutrons, which will give you 2.016 atomic mass unit. Then after that, we'll calculate the mass defect for the formation of deuterium. So it'll be 2.016 minus 2.0141, which will give you 0.0019 atomic mass unit. Then we can calculate the binding energy, which will be 0.019 times 933, which will give you 1.8 mega electron volt. In part 2, we have to calculate the binding energy per nucleon of zirconium. We have to do this calculation in 4 steps. In step 1, we calculate the total mass of the individual protons and neutrons. Zirconium is 9740. This 40 represents the proton number and 97 represents the number of protons and neutrons. That means in zirconium nucleus, we have 40 proton and 57 neutron. So the total mass of the individual protons and neutrons will be 40 times the mass of the proton plus 57 times the mass of the neutron. This will give you 97.7879 atomic mass unit. In step 2, we calculate the mass defect. Mass defect is the difference of the mass of the individual protons and the mass of the zirconium nucleus, which will be 97.7879 minus 97.0980. This will give you 0.6899 atomic mass unit. Then in step 3, we have to calculate the binding energy. We know that your mass defect is binding energy, so use E equals to mc squared to calculate the binding energy. So E equals to 0.6899 times 933, because we know that one atomic mass unit is equivalent to 933 mega electron volt. So this will give you 643.7 mega electron volt. Then in step 4, divide the binding energy by 97, since the zirconium has 97 protons and neutrons, to calculate the nuclear binding energy per nucleon. So this will give you 6.64 mega electron volt.